Remember Hive and Pig?
Oh yeah, Hive and Pig.
These are two more crucial components that play a vital role in making big data more accessible and manageable.
Right, Hive and Pig. We talked about them briefly earlier. Remind me again what they do and why they're so important.
Hive is a game changer for those familiar with SQL, the language of traditional databases. It provides a SQL-like interface called HiveQL that allows users to query data stored in Hadoop without having to write complex MapReduce code. It's a huge time saver and makes big data analysis accessible to a much wider audience.
So it's like Hive is the translator between the SQL world and the world of big data.
Right.
You can speak SQL to Hive, and it translates that into something Hadoop can understand.
Exactly. It's like having a bilingual friend who can help you communicate with someone who speaks a different language. And Hive doesn't just query data, it also provides tools for data warehousing, allowing you to organize and structure your data for efficient analysis. It's like having a well-organized library for your big data.
Hive, the SQL Whisperer, and Big Data Librarian. What about Pig? How does it fit into all of this?
Pig is another high-level scripting language that simplifies data processing in Hadoop. It uses a language called Pig Latin, which is more procedural than SQL, but still relatively easy to learn. Pig is particularly useful for data transformation tasks, allowing you to manipulate and reshape your data before analysis.
So if Hive is the translator, Pig is the data sculptor, molding and shaping the data into the form we need.
That's a great way to think about it. Both Hive and Pig play important roles in making big data more manageable, providing powerful tools for querying, analyzing, and transforming vast amounts of information.
This is all fascinating stuff, but I have to admit, my brain is starting to feel a bit overloaded.
Sure.
We've covered MapReduce, Spark, Hive, Pig, all these powerful tools for processing and managing big data. It's a lot to absorb.
You're doing great. It's true, the world of big data is full of specialized tools and technologies, each designed to handle specific aspects of data processing. And as we delve deeper into the realm of big data, we'll encounter even more specialized tools and techniques. But for now, you have a solid foundation to understand the core components and the general workflow involved.
Okay, so we've explored the foundations of big data processing, from MapReduce to Spark, and even touched on helpful tools like Hive and Pig.
That's right.
What's next on our big data adventure? What's next on our big data adventure?
In the final part of our deep dive, we'll journey into the fascinating world of NoSQL databases and explore how they're revolutionizing the way we store and manage data in the age of big data. Remember those flexible and scalable databases we discussed earlier? We'll take a closer look at how they work and why they're so important.
I'm ready to dive into the NoSQL world. It's been an incredible journey so far.
Welcome back for the final part of our big data deep dive. It's been quite a journey, hasn't it?
It has.
We've explored the sheer scale of big data, the power of MapReduce and Spark, even those handy helpers like Hive and Pig.
And now, as promised, we're going to explore the fascinating realm of NoSQL databases.
They really are revolutionizing how we store and manage data in this era of big data.
NoSQL, the rebel of the database world. Breaking free from the limitations of traditional SQL. We touched on this earlier, but I'm ready to dive deeper. What sets these NoSQL databases apart from their SQL counterparts?
One of the most fundamental differences lies in the concept of schema flexibility.
Yeah.
Traditional SQL databases operate on a fixed schema. You have to define the structure of your data up front. All those tables, columns, and data types before you can even begin.
It's like creating a rigid blueprint for your data. But what happens when your data changes or you need to incorporate new information that doesn't fit that blueprint?
Yeah.
That seems like it could be a real problem in the ever-evolving world of big data.
Exactly. That rigidity can become a huge bottleneck.
Right.
What if your data structure evolves over time? What if you need to integrate new sources with different formats?
And that's where NoSQL shines, right, with its adaptable approach.
Absolutely. NoSQL databases embrace schema flexibility. You can store data without having to predefine its structure. This makes them perfect for handling unstructured or semi-structured data. Think social media posts, sensor readings, or those complex JSON documents we mentioned before.
Hold on, JSON documents. We've mentioned those a few times. What exactly are they?
Ah, good point.
Yeah.
Think of JSON like a digital filing cabinet. It's a way to organize data using key-value pairs, but it can handle lots of nesting and complexity. So you can store all sorts of information in one JSON document, like a customer's profile with their name, address, order history, all that in one neat package.
Okay, that makes sense. So NoSQL is like having a database that can adapt and grow with your data, accommodating those different formats. What about the issue of scaling? We talked about how vertical scaling has its limits.
Right. Eventually, you hit a ceiling with how much power you can pack into a single machine. NoSQL databases tackle this challenge by embracing horizontal scaling. That means distributing your data across multiple servers. As your data grows, you just add more servers to the cluster, and the database takes care of the distribution and management behind the scenes.
So instead of one supercomputer struggling to keep up, it's more like a team of computers working together, each handling a portion of the data load.
Exactly.
Makes sense. Is that what makes NoSQL so resilient?
It certainly contributes.
Yeah.
This distributed architecture naturally lends itself to fault tolerance.
Oh.
If one server in the cluster goes down, the others can pick up the slack. That ensures your data is safe and the system remains available, even if there are hiccups along the way.
Okay, so NoSQL is a flexible, scalable, and resilient. It's like the superhero of databases.
Right.
But I remember you mentioning different types of NoSQL databases, each with their own strengths. Could you remind us what those are?
Of course. We have key value stores, document stores, column family stores, and graph databases. Each is optimized for different use cases.
Let's start with key value stores. Those sound pretty straightforward.
They are. Key value stores are the simplest type of NoSQL database. They store data as, you guessed it, key value pairs. The key is a unique identifier, and the value is the data associated with that key. Think of it like a dictionary. You look up a word, the key, to find its definition, the value.
So it's like a giant, super fast lookup table. When would we use this type of database?
Key value stores excel at handling simple data structures and retrieving data quickly based on a key. They're often used for caching frequently accessed data, storing session information, or managing user profiles with basic attributes.
Got it. So for speed and simplicity, key value stores are the way to go. But what if you have more complex data, something like those JSON documents you explained earlier?
That's where document stores come in handy.
Yeah.
They're designed to handle those complex nested data structures where each document can have its own unique structure. They're a popular choice for product catalogs, content management systems, or any application that requires flexible data modeling.
It's like document stores are the all-terrain vehicles of the NoSQL world. They can handle anything you throw at them. What about those column family stores? They sound a bit more specialized.
They are. Imagine a giant spreadsheet where each row represents a record and each column is an attribute. Now imagine grouping related columns into families. That's the essence of column family stores.
Okay.
These column families are stored and accessed together, making them incredibly efficient for retrieving specific data points across large data sets.
So it's like slicing and dicing your data by category?
Yep.
That would be perfect for analytical queries where you're looking for trends or patterns, right?
Exactly. They excel at handling time series data, sensor readings, or anything where you need to analyze trends over time.
Okay, that leaves us with graph databases. What makes them unique?
Graph databases are all about relationships. They represent data as nodes and edges. Each node is an entity, like a person, a product, or a location. And each edge represents a connection between those entities. Think social networks. Each person is a node, and their friendships are the edges connecting them.
So it's like mapping out the connections in a complex network. I can see how that would be useful.
Okay.
What are some real-world applications of graph databases?
They're great for anything that involves understanding relationships,
Okay.
social networks, recommendation engines, fraud detection, even knowledge graphs that map out connections between concepts and ideas. If you need to analyze how things are connected, graph databases are the way to go.
This whole world of NoSQL is fascinating. It's like the Wild West of databases with all these different approaches and specialized tools for handling different types of data.
It's a dynamic and evolving landscape, that's for sure. And as we generate more data and explore new applications, the importance of NoSQL databases will only continue to grow.
Well, this deep dive has been incredible. We've covered so much ground, from the fundamental characteristics of big data to the intricacies of MapReduce and Spark to the flexibility of NoSQL databases. It's clear that big data is not just a tech buzzword. It's a revolution that's transforming our world.
I couldn't agree more. And it's not just about the technology itself, it's about the possibilities it unlocks. Big data is changing how we understand our world, how we make decisions, and how we solve problems.
So as we wrap up this epic journey, what are the key takeaways you'd like our listeners to remember?
First and foremost, big data is more than just size. It's about the challenges and opportunities that arise when we're dealing with massive amounts of diverse, dynamic, and often unstructured information.
It's about the need for new tools, new technologies, and a whole new way of thinking about data.
Exactly. We've explored powerful processing frameworks like MapReduce and Spark, the versatility of NoSQL databases, and the importance of specialized tools like Hive and Pig that make big data more accessible.
We've seen how big data is transforming industries, from healthcare and finance to retail and scientific research. It's impacting our entertainment choices, our shopping habits, our health, and so much more.
And most importantly, it's not just a technological phenomenon. It's a cultural shift that requires us to rethink how we collect, analyze, and leverage information to solve problems and create value.
Big data is not just for tech giants or data scientists. It's a force that's shaping our world, and understanding its fundamentals is essential for anyone who wants to thrive in this data-driven age.
Absolutely. So as we conclude this deep dive, we encourage you to continue exploring the world of big data. Stay curious, stay informed, and embrace the transformative power of information.
And that concludes this episode of The Deep Dive. We hope you've enjoyed this journey into the fascinating world of big data. Until next time, keep diving deep.